We're here at InfoBlocks for a podcast series on DNSSEC with Cricket Liu, the Vice President of Network Architecture at InfoBlocks. In this topic, we're going to talk about DNSSEC. I'm John Furrier with the blog Broad Dev, and we've had a chat before about DNS and other things.
We have.
But this podcast is about DNSSEC. So tell us what DNSSEC is.
Well, DNSSEC is a shorthand for the DNS security extensions, which are a proposed group of extensions to DNS to add better security, basically security that wasn't envisioned back when we came up with the original specifications for DNS. So DNSSEC uses asymmetric cryptography to allow us basically to digitally sign zone data.
Where did it originate from?
Well, it's been around for quite a while, actually. I just looked it up. One of the original RFCs on DNSSEC, written by Donald Eastlake when he was at IBM, was from 1999. So it's been around for a while. It was really a product of the IETF, of the Internet Engineering Task Force.
DNS has been in the news lately. We've talked about the cache poisoning stuff. Why is DNS important today?
Why is
DNSSEC. Why is DNSSEC important today?
Well, the recent Kaminsky vulnerability, which allowed or would allow hackers to poison the caches of name servers around the Internet, is one that could be directly remediated by DNSSEC. So DNSSEC, if it were completely adopted, completely deployed, would make that sort of attack almost inconceivable.
What does DNSSEC involve? I mean, obviously it's the DNS that makes it more secure for those reasons, but what does it really involve and how would it work?
Well, from an administrator's standpoint, DNSSEC involves creating a key pair for every zone that's under your control, a public key and a private key, and then using the private key to digitally sign all of the RR sets in your zones. RR sets are groups of resource records that are attached to the same domain name and have the same type. And then what gets added to the zone is a new type of a resource record called an RR-SIG record, which is basically the digital signature of your zone's private key covering that RR set.
Why are people doing this today? Why is it important for folks who have DNS running their infrastructure to have this kind of signature? Because obviously it's DNSSEC security, but really what is the core reason why they're going after this?
Well, the main reason that you want to have signed data is so that people can verify the authenticity and the integrity of that data, because so much rides upon DNS, so much depends upon DNS today. You want to make sure that your electronic mail is really going to the right place. You want to make sure that your users are actually going to the websites they think they're going to. That all your electronic transactions that go out over the Internet or even over your internal network go to the destinations that you want them to, as opposed to something that's been spoofed by some hacker.
So from an IT perspective, from an infrastructure perspective, how should people look at DNSSEC? Obviously, in terms of benefits, but more importantly, as they look at, do they deploy it or not? What are some of the challenges and what are the benefits that they would get from looking at DNSSEC?
Well, the challenges are that DNSSEC does add administrative complexity to your environment. You have to generate key pairs. Managing signed zones is more difficult than managing unsigned zones. Every time you change any piece of data in a zone, you actually have to re-sign the zone data. The tools that are available right now for managing signed zones are relatively primitive. They're command line tools.